Why are autonomous collision avoidance systems hard to certify? Imagine a robot or self-driving car navigating busy streets or complex factory floors. It must avoid obstacles perfectly every time, no matter what. That's where collision avoidance systems come into play. These systems use sensors like cameras, LiDAR, and radar to spot obstacles and plan safe routes. They need to interpret data quickly and make real-time decisions to prevent accidents. But certifying these systems as safe is a huge challenge. One big reason is environmental variability. Weather conditions like rain, fog, or snow can mess with sensor accuracy. Low light or glare can also cause sensors to give false readings. Urban areas with many obstacles make it even harder for systems to stay reliable. If sensors can't see clearly, the system might miss a hazard or react too late. Sensor and system reliability is another hurdle. Sensors can fail or degrade over time. Mechanical parts like brakes or steering can wear out, and software bugs or hacking risks add more uncertainty. Certification needs proof that the system can handle failures safely and switch to backup modes if needed. Autonomous systems often use machine learning algorithms that don't always give the same answer for the same situation. This unpredictability makes certification tricky because safety standards usually want systems to behave predictably. If a system makes different decisions in similar situations, it's hard to prove it's safe. Balancing false alarms and missed threats is also complex. If the system overreacts, it might cause unnecessary stops or sudden maneuvers. If it misses real hazards, accidents can happen. Finding the right balance is tough because it depends on many factors and different scenarios. Making decisions like a human adds more difficulty. These systems need to interpret traffic laws and react to unpredictable behaviors from pedestrians or other vehicles. Meeting or exceeding human judgment standards is a high bar for certification. Testing is another big challenge. Real-world collision scenarios are rare and diverse. Collecting enough data to cover all possible situations is nearly impossible. Simulations help but can't replicate every edge case. Without enough real data, proving safety becomes harder. Formal verification methods, which mathematically prove a system's behavior, are still developing for AI-based systems. Traditional safety standards are designed for predictable, rule-based systems, not for learning algorithms that adapt and change. This mismatch makes certification even more complicated. In practical terms, certifying these systems involves extensive testing of sensors, algorithms, and hardware. It requires demonstrating that the system can handle different weather, lighting, and obstacle scenarios. It also means proving cybersecurity measures are in place to prevent hacking. Certification bodies want evidence that the system will behave safely in all expected conditions. Developing standards that account for the probabilistic nature of AI is ongoing. It involves creating new testing protocols, safety benchmarks, and validation methods. This process takes time and collaboration across industries, regulators, and researchers. So, the reason why autonomous collision avoidance systems are hard to certify is because they must perform reliably in unpredictable environments, handle sensor failures, and make complex decisions. They use advanced algorithms that are not always predictable, and real-world testing is limited. All these factors combine to make certifying these systems a complex, multi-step process that needs careful validation and new standards. Understanding these challenges helps explain why making autonomous systems truly safe and certifiable is such a big focus for researchers and engineers working in robotics and emerging autonomous fields.